Hello students, in continuation with our assertion and reasoning series, today we'll take up questions on current electricity. In our previous discussion, in first discussion we have done how you should approach assertion and reasoning type questions. After that we have taken the first chapter, that is the electrostatics. And in today's discussion, we are going to discuss questions on current electricity. Here, if you see that the different options which are given there, it is same. The fourth one is assertion and reason both are wrong statement. Third one is the assertion is correct and reason is false. Okay. So assertion is resistance of superconductor is 0. This is true because we take that resistance of the superconductor to be very, very small there. So practically they will be very small, but we can consider that it is almost 0 there. Reason is superconductor are used for electrical power transmission. Okay, superconductors we are using for power transmission. This is also true, but is it the correct explanation for the assertion? Let's see that resistance of superconductor is 0 because superconductors are used for electrical power transmission. This is not explaining that why the resistance should be 0 there. So obviously this is not the correct statement there or explanation there for the assertion. So second one, that is B, will be the correct option there. Let's take the next question. Again, it is the same options there. Assertion is the domestic electrical appliances working on 3 pins will continue working if the thick pin is removed. Now, this is true. Many appliances, if you see, there will be having 3 pins. Basically, the third pin is there for safety reason. Basically, it is for the earthing of the appliances there. So, you will have the 2 pins there basically, which will be used for passing electric current through the appliances there. Okay. So, one is your live one and the other is the neutral one. So, this is true. If it is removed, that is the third one which is used for the earthing. So, that pin if you are removing, in that case it will continue to work. And the reason is given that the thick pin is used only as a safety device. This is basically the correct reason there. We are using it for the earthing of the appliances there, so that in case of any extra discharge there or the flow of the current, if the appliances gets defective, so there should be the flow of the current through the earth and not to the person who is touching it, or he gets an electric shock there. So again, if you read the statement there, that a domestic electric appliance working on 3 pin will continue working if the thick pin is removed because the thick pin is used only as a safety device. So it is explaining it correctly there, the assertion. So the first one will be the correct option. Let's take the next one. Again, same set of options are there. So let's take the assertion. Same amount of current flows through the filament and the line wire, but more heat is produced in filament. Obviously, it's correct. The current which will be flowing through the line wire as well as to the filament there. And more heat is produced in the filament. This is true. Filament is made of material having high resistance and high melting point. This is also correct. Now, here you can see that both are true. So, if you read the entire statement there, the same amount of current flows through the filament and line wire, but more heat is produced in filament because filament is made of material having high resistance and high melting point. So obviously it is clear that if resistance will be high, in that case more heat will be produced there, and that since it has more resistance there, so obviously more heat will be produced in it. So the first one is the correct option. Let's take the next question. Assertion is in balanced condition, the galvanometer, if the galvanometer and the voltage source is interchanged, the balanced condition remains same. So here, if you take any Wheatstone bridge arrangement and you are taking suppose this, here suppose I call it as your P, Q, R and S. Basically we have the galvanometer here and we connect the source on this side. It is said that in balanced condition, we are interchanging the voltage source and the galvanometer. So their positions are being interchanged. So if you see this particular arrangement, if you are using suppose the voltage source here and galvanometer in this particular position, in this particular case what you have, P by Q equals to R by S. Now it means this is giving you PS is equals to RQ. Now if I replace this, suppose if I put a source here and the galvanometer in this particular position. So again, across the galvanometer, if you see, it will be the same set of resistance combination will be there. So again, in this particular case also, for the galvanometer, it is now connected here, basically. So it will be your R into Q and P into S. So it will be the same one. So obviously this will remain same. That means it is true. And reason is given that the balanced condition of Wheatstone bridge does not depend on the value of the resistances. This is not correct. It will depend upon the value of the resistances. That is why if you get P by Q equals to R by S, then it is in balanced condition. So only if you get the balanced condition, then there will be no current flowing there. So this is false. So obviously in this case, the assertion is true, reason is false. So third one will be the correct option. So let's take next question. Again, options are same. Assertion is the value of temperature coefficient of resistance is positive for metals. For metals it is true because for metals we get R equals to R naught 1 plus alpha T. Of course plus beta T square is also there. But if I restrict the expression to the first part of the temperature there, and that means we are neglecting for beta, in that case it will be the relation there. And for metals, the value of alpha is positive. That is why if you take the positive value, when you are increasing the temperature of the metals, then this resistance will increase. So that means this is true. And the reason is given, the value of the temperature coefficient of resistance is negative for insulator. This is also true. But now if I just read it again altogether, the value of temperature coefficient of resistance is positive for metal because value of temperature coefficient of resistance is negative for insulator. This is not explaining it to the assertion part, or it is not the correct explanation there. So obviously in this particular case, B will be the correct option. Let's take the next one. Again, it is the same set of options are there. Now, assertion, the balancing point of a meter bridge is obtained at 40 centimeter. When the area of cross section of the wire is doubled, the balancing length shifts to 60 centimeter. Now, suppose if I take the meter bridge, here you have suppose this as the meter bridge. This is the gap in which you are connecting one resistance. This is the another one. And we have the source connected here along with the key and other. And this is the position of the galvanometer. This is the jockey. This is suppose your R and this is your X. This is your AB. Now in this case, what happens there? In balanced condition, you will have a R by X equals to resistance of AJ by resistance of BJ. Now suppose it is there that in one particular case we are getting the balancing length as 40 centimeter. That means say it is your AJ is 40 centimeter. We are increasing or doubling the area of cross section of the wire. So when you increase the area of cross section of this wire, then its resistance will change. And if its resistance is changing, in that case, what will happen? Like here, I can take this one resistance, I can take it as your lambda into L1 by lambda into L2, where lambda is resistance per unit length. Now here, if you made this wire to have the double area of cross section, its resistance will change. And if the resistance of the meter bridge wire is changing, it means resistance per unit length will also change. We are not changing its length, we are only changing resistance there by changing the area of cross section there. So in that case, what will happen? Now instead of lambda, it is your lambda dash. So it is lambda dash L dash, lambda dash L double dash. For this particular case, R by X we have not changed, so it is your L1 by L2. And here R by X will remain same in the second case also. Lambda dash will get cancelled, so it is your L dash by L double dash. It means this L and L dash, L1 and L dash, L2 and L double dash, both will be same. So that means this is the false one. Then second one is resistance of a wire is directly proportional to area of cross section. This is also false. Resistance of a wire is inversely proportional to area of cross section. R is equals to rho L by A. So if the length and remains same and material is same, then it is inversely proportional. So that means assertion and reason both are false. So it is the fourth one, which is the correct option. Let's take next one. Potentiometer is used to measure the EMF of a cell. Now this is true. We use the potentiometer to measure the EMF of a cell. That is how we are using potentiometer experimentally also to measure the EMF of the cell there or compare the EMF of the two cells there. Potentiometer is preferred over voltmeter to measure EMF of a cell as it does not draw any net current from the cell. That's true. In the balanced condition, it will not be drawing any current. So this is also true. So now let's read out the two statements together. Potentiometer is used to measure the EMF of a cell because potentiometer is preferred over voltmeter to measure the EMF of a cell since it does not draw any net current from the cell. So in this case, here it is explaining it properly that why we are using potentiometer to measure the EMF of the cell over the voltmeter, because it will not draw any current in the balanced condition there. So obviously the first one will be the correct option. Let's take the next question. Assertion is the resistance of conductor increases with rise in temperature. And the reason is given, the value of temperature coefficient of resistance is positive for conductors. So again, here if you see the resistance of a conductor increases with rise in temperature. This is a correct statement. It is true. And the value of temperature coefficient of resistance is positive for conductor. This is also true. Now let's see the whole statement together. The resistance of conductor increases with rise in temperature because the value of temperature coefficient of resistance is positive for conductor. So it is explaining it correctly there that why the resistance of the conductor should increase with rise in temperature. So the first one is the correct option. Let's take the next one. Again, it is the same set of options there. Assertion is conductivity of metal is much higher than that of the electrolyte at room temperature. Okay, this is a correct statement, true. And the reason is the free electron density in metal is much less than the density of ions in electrolyte, and the free electrons have a smaller mobility than ions. Now this is false. Free electron density in metal is much less than that of the density of the ions in electrolytes, and also the free electrons have smaller mobility than electrons. This is false. So obviously assertion is correct, reason is false, so it is the third one which will be the correct option. Let's take the last one. When identical cells are connected in parallel to an external load, the effective EMF increases. Now here identical cells are given and they are being connected in parallel to an external load. So suppose if I take the cells, these are suppose the cells, each have the EMF E, and they are now suppose connected to a load. This is the load resistance, suppose R. So if it is connected there, then effective EMF will remain same. That means it will remain E only. So effective EMF increases if it is said, that means this is false. Effective EMF will increase if the cells are joined in series. So here it is joined in parallel, so it is false. And the reason is that all the cells will be sending unequal current to the external load in the same direction. If all cells are having same EMF, they all will be sending the same amount of current through the same load, because they all are connected there individually in parallel, and then they are connected to the resistance there. So obviously this is also false. So now in this case, assertion is false, reason is false. So that means it is the fourth one which will be the correct option. This was our discussion on assertion and reasoning type questions on current electricity. In our next discussion, we'll take a magnetic effect of current and magnetism.